Alright, time for another DraftScience video presentation. So we're back on kinetic energy. The beginnings of a written statement of some kind. Obviously would have to add more details about why you should understand that it's true, that it's just a junky theory. Bad origin. The whole process, the bad at the start, bad in the middle, bad right now, and the fact that people won't admit this isn't what science should look like, just illustrates the point that people are just gang members, the sheeple, the herds, whatever. They just can't function as individual thinking people and do it with some sort of integrity. They have to do it from a personal biased perspective, where they are, they'll defend things that aren't, that they usually wouldn't defend, just to get what they want as an outcome. They'll have allies who are as corrupt. They'll give money, to Osama bin Laden, because he's anti-Russian. That kind of thing. Just despicable. It's just sad that that's the planet we live on. They illustrate it in terms of what kind of response this channel gets. Just illustrates the point. Conventional physics is allowed to cheat the truth all over the place. I can't make semantic errors. I can't say the wrong word. Just so pathetic. Alright, anyway. So this is MV versus 1/2 MV squared, which originally started as, just MV squared. And that's its origin. That's just a part of the historical fact that the original theory was accepted in a form that was completely not very good. Wasn't even close to accurate. And they accepted it, okay, because it's just about an agenda. It's more political than it has anything to do with science. So anyway, the kinetic energy theory has a very unscientific history. So the history is Leibniz. He's the originator of it, and then it was picked up after Leibniz's death, resurrected, so to speak, by a bunch of crystal rubbers. People looking for just to be gothy and different. Okay, people who just wanted to protest the establishment in a sense, and nothing more. But anyway, so its purpose was, it originated as a protest against physics becoming too atheistic. That's almost exactly the words Leibniz used in describing his fear of what Descartes and Newton were up to. And this was clearly just a protest against the fact that it looked like there was no place for God in the scientific investigation. We weren't finding God, and Leibniz thought we should be. And to satisfy a desire that science complement religion. So the simple truth was, he believed God would create a certain kind of world, and Descartes wasn't describing that world, and therefore he had to redescribe the world in some way that made it more sensible to believe in the magic bits. Anyway. Alright, the evidence supporting the kinetic energy theory is weak to non-existent. I mean, this is a subject you can go on and on about. So let's first talk about in the 1700s, when this really got kick-started. The idea was resurrected. Leibniz pretty much died a failed scientist, in the sense that he had been pretty much universally understood to have stolen, copied, plagiarized Newton's calculus, and he didn't win any points with scientists arguing for this MV squared thing, because there was no evidence for it. and there was no reason to believe Newton had it wrong. And that's the simple truth. Newton's mechanics worked, and there wasn't any need to change it, and that was a fact. All right, and so in the 1700s, these clay experiments were done that you could, frankly, easily engineer to produce whatever results you want just by changing the composition of the clay. You could make the test instrument, okay, tell you whatever you want to know, whatever you want the result to be. If you made your clay out of cornstarch, you would have the formula they'd be defending now would be 1/2 Vm squared, because it would seem like mass was the important factor. So it's really a bad scientific proof, a bad argument to make, just because it isn't what experiments are supposed to be, which is repeatable, and it's just really bad science, really bad physics. And so there have been no modern experiments proving the existence of any energy beyond momentum. So you can see lots of experiments where you see momentum conserved, but there are no experiments. So I guess we'll go through a couple of the experiments and the fact that we have no example of them. So the simplest one is a bowling ball example, or a 10-ton train example, where you take something that has twice, it has an inverse mass to velocity ratio. So the idea would be is that you have something that's 5 tons and 10 masses, 10 velocities, sorry, and a similar train that is the exact opposite ratio. It's 10 tons and it's only going 5 V's. And the argument is that the momentum is equal, but the kinetic energy is not. This one is claimed to have twice, 2x, the energy. Alright, so we have no experiment. No bowling ball, so this you could just change it into a bowling ball and say you have a, this is your 8-pound bowling ball here, going twice as fast as your 16-pound bowling ball. And we have no evidence that the 8-pound ball will knock down twice as many pins, that it'll transfer energy. Transfer energy. That's what happens in the real universe, is the energy has to be transferred from one object to another. It can't give it something it doesn't have. The whole point of the universe is the conservation of energy itself. So anyway, so we have no example. So there's just nothing. They never put generators on these wheels, of any device, of comparable devices. They've never in any way done the experiment in some way to extract what would be called the energy, the joules. They're saying this one has 100 joules over here. They're saying this one only has 50. And they have absolutely no experiment showing us that. Nothing. Nothing to show us that it took twice as much work, or to move it, or that it makes twice as much work. No evidence of this one, somehow in the conversion process, if I was just to bang this 5-ton cart into a stationary 5-ton cart, the evidence is that, momentum perfectly works. I can drop the weight on. I'll end up with this cart at the end. I won't have deformed anything or set anything on fire. And they're still claiming somehow I lost twice the energy. Somehow this product has half the energy, even though there'll be no example or any evidence that there's any place for all that energy to have gone. They won't collect the lost energy. So even though we say it has to be conserved energy overall, they won't show us where it all went. They'll just say somehow it deformed, and somehow it did this, and somehow it did that. But there won't be any evidence that it did any of those things. So I could also use the example where they often say that, if you're going 30 miles an hour and you increase your velocity to 60 miles an hour, that somehow, okay, so if you're just going, you decide to go 30 miles an hour, you'll use a certain quantity of gasoline. And if you want to go 60 miles an hour, you'll use 4 times as much. That's a simple enough experiment to do. Well, why don't you show me? Why isn't there a single bit of experimental evidence showing that it takes 4 times the energy to produce this outcome of going 60 miles an hour? See, they're using the opposite effect. They're saying it takes twice, 4 times as much braking energy, but it really doesn't. If you apply the brakes proportional to the masses, it doesn't take 4 times as much. So they don't have any evidence of any of this, as stated in here, at the end. Friction isn't a force. It isn't some counter force. Friction is you actually giving away your energy to another object, a surface. You're hitting it, and you're hitting little bits of it, and you're giving them momentum, your momentum. When a bowling ball hits a bowling pin, it's not doing something magical, it's giving it a momentum. And that momentum has to come out of its momentum. It goes slower because it makes the pin go faster. And that's friction's the same thing. Friction's just little pins that you're moving and taking away your energy. But all you have is the MV. There's no reason to square it. There's no logic to it. Doesn't make any sense. And there's just zero evidence, really. I mean, the clay experiments are zero evidence because it can be understood that obviously I just changed the composition of the clay. I changed the result. I can make it 4 times. I can make it 2 times. I can make it 3 times. I can make it any kind of number just by changing the composition of clay, because clay has a bias for velocity. There are substances, that react to velocity. And as I point out, cornstarch reacts exactly the opposite. It lets the slow thing go right through, and it stops the fast thing right on the surface. So you get exactly the opposite disproportions. Just use a different substance as your clinical thermometer. So it's just terrible physics. Again, there's no experimental evidence, even though it's pretty obvious and simple to acquire that experimental evidence. And I should even go into the weight argument, that they've never even converted their sacred jewels into what they should be converted into, which is weight. Because that's what a joule is, by definition. It's the weight of a stick of butter dropped 1 meter. That weight, that deflection on a scale, is a joule. And so we should just be able to convert all of this into just understanding everything as a pressure that something will apply, a weight. Then gravity is doing the same thing. Gravity is just changing your weight by adding motion. And if the motion is in this direction or this direction, it really doesn't matter. When you hit something, you're going to hit it with an impact that's based on your mass and your velocity. And there is no, 1/2 mv squared. Could do the mathematical formulation, but there's no point at this point. So we'll see what excuse. Well, the excuse will be it's written down here. All right. So the evidence is weak to non-existence. The clay experiments of the 1700s were obviously dubious as scientific proof. So I mean, anybody who's going to take science seriously would see the less than perfection of using clay as a thermometer. It's not a very good thermometer. There have been no modern experiments proving the existence of any energy beyond momentum. So again, there's just nothing. There's no experiment they can point me to. There's no evidence, nothing. No reason to believe. No good reason. It's not Newton's mechanics. It was started by a religious fanatic. It was defended by people in almost the same category, looking for something special. They're looking for special physics. Something to make humans more significant. Okay. The formula creates free energy paradoxes. Well, the obvious paradox is I just bang, heavy things into light things, and I can just keep making free energy. Because the light thing will interpret the energy as being more energy. And so there's lots of physical devices you could imagine creating that take the kinetic energy formula and just exploit the fact that it creates as much energy as you want, free energy, because the definition is so wrong. So I guess that's worth illustrating with, say, the lever. So we will do that. So this is the part where it's, it's hard to write up the descriptions of experiments, and so that's where writing fails. So if I have a lever, and let's try to make it as perfect as possible, some sort of perfect little hinge here, and so you understand that you're going to put pressure on it at a location. So we'll just mark it with locations, that are equidistant. Okay. And so say if I have the 5-ton weight, or the 5 mass here, and you could argue that, if I put a 5 mass object here, that it's going to be balanced, and that if it was tipped and I had to lift 5 mass, that's what it would weigh, 5 mass. So let's just say there's no mass on here, and I'm going to apply a pressure here to equal that pressure, to lift that pressure. There's really no way to tell the difference. If I put a 2.5 mass here, okay, will you be able to tell the difference between let's say I'll put the 5m here just so you understand relationships. So the 5 mass is here, the 2.5 mass is there. Alright, if I blindfold you and I put this one on the scale, and then I do this one on the scale, are you going to tell me you could tell the difference? That there's some mechanism going through that's going to tell this area of the lever that there's a different amount of mass here? Well, no, of course there isn't. So there's no logic to this, in the sense that what I can do is, merely keep things going faster. So I can just drop the 5 here. Alright, if I drop a 5 here, and I put a 2.5 out there, or let's just say I put a 5 out there. Alright. Well, no, I have to halve the mass. So I put half the mass out here, 2.5. Get rid of this for now. It's going to leave with twice the velocity. Alright, so that would be the theory, right? This comes down with a 10v. This is going to be twice as far away. It's going to leave with a, 2x the v, so it's going to be 20. And by the kinetic energy formula, that's going to mean that this one's going to have twice as much energy. So I put a certain amount of joules in here, 50, and I get 100 out of here at this end. That's the simple paradox created. We can use the rocket ship example also, simple example. I mean, where you can just keep gaining more and more energy by already acquiring velocity. So the same amount of energy in, right? You have 10 joules worth of energy, 10 calories of food. You put it into the rocket. Well, if the rocket's already going 100 miles an hour, and then it's going 500 miles an hour, you're going to get more energy out of the same calories. I put the same calories in, the same amount of thrust comes out, but if I'm already going 500 miles an hour, somehow the calories are going to make more and more energy. So it's, again, this doesn't make any sense. It's non-conservative. Doesn't fit with Newton's third law. I can also use the example of the rocket ship with the simple navigational thrust, saying, I just eject 2 objects, 2 kilograms over here, and a dime, 0.002 grams over here. I think it's 0.02, but anyway, it doesn't really matter. I mean, it matters, but it doesn't really matter. This one leaves 1,000 miles an hour. It's 1,000 times difference in the weight. This one leaves at 1,000 miles per hour. This one leaves at 1 mile an hour. Okay. Their argument is, that somehow it took 2,000 joules of energy. That's what it would come out to, 2,000. It takes 2,000 joules of energy. 2,000 joules to create that. It only takes 2 joules to create this. And yet, if you do this in space, this, okay, is going to equal this. Your spaceship's going to keep going straight. It's not going to go a tremendous amount this way because you shot all of this energy out. And then they've never collected. Again, the simple argument is they've never they've never taken the bullet coming out of the gun and shown that it has thousands of times more energy than the stock of the gun. They say equal and opposite reaction. They say the gun, okay, will move that way with an equal amount as the bullet goes out this way. And yet the problem with that is they say this bullet has the 2,000 joules, and they say this gun only has the 2 joules of energy. This can only do 2 units of work. This can do 2,000 units of work. How is that equal and opposite? So it violates, you know, the laws they've claimed to be quite sacred and quite reliable. It's a clear violation of that law. This is hardly an equal and opposite reaction. 2,000 joules, 2,000 slaves going this way, 2 slaves going that way. Workers, ability to change the universe. So it doesn't make any sense. It completely breaks all the other physics, and yet people are going to tell me I'm an idiot because I don't believe it. Even though they've provided 0 evidence. They've given me 0 evidence that this does less work. That the force of the gun is less than what the bullet will do. Now obviously the gun does expel some of the force this direction in the form of air pressure. So not all of the energy goes into the gun. So to make the gun collect more of the energy, you have to really force the gun to do some reloading, do some different, do some work inside of the gun. So it definitely collects all of the energy in this direction, But anyway, I mean, if I just made a gun with a hollow tube, a zip gun, for example, but a zip gun isn't a perfect example unless you have it ignite by, electricity or something. But if I just make that device and I put a bullet in it, okay, the barrel isn't going to have nearly the recoil, okay, when I shoot a bullet out, because a lot of the energy is just going to freely go into pushing the atmosphere, not pushing your hand that's holding the barrel of the gun. Only a certain percentage of the energy pushes on the barrel, and a great deal of the energy will just shoot out the back of the gun. But anyway, I mean, this is basic physics, and the fact that I have to make these videos talking about these simple effects, and the fact that they have no evidence, that they've never documented any of this as being a truth. There's no experiment you can go to, none I can link you to, none that I can show you their evidence, them proving that it takes 4 times more gasoline to go 60 miles an hour than it takes to go 30. Not a single frickin' experiment proving that. It's just a claim they make. And then they call you names if you don't believe. It just really is horrible. Anyway, the formula clearly challenges the validity of Newton's third law. So I've sort of pointed that out, that there's lots of scenarios you create and it doesn't make any sense because somehow, even the little train example, an explosion between 2 trains. Okay, one's twice the mass, one's half the mass. I explode something between them. They both get equal energy. But somehow one train has twice as much energy. Again, the lighter train somehow absorbs the energy more completely or does something, who knows what. Or in their argument, less than. But somehow they convert this into some sort of excuse to say what happens didn't happen when it clearly did happen. The cart that has twice the mass goes half the velocity. And that makes perfectly good sense as momentum being the truth. And yet I'm supposed to believe that something went wrong and one of them has twice as much energy as the other. When there's no reason to believe. So anyway, so yeah, it just blows up Newton's third law. and they won't even admit that. Alright, let's, I don't know why this, I should have added some extra spaces here, I guess, just to give this scrolling capacity. Alright, the formula is not a rational derivative of Newton's mechanics. Okay, so this is just their derivations come in a couple of different forms to create the square and the 1/2. So they take what Newton actually believed and said and wrote, all right, which is force, okay, equals your momentum, okay, written. Let's do it as, your change in momentum, which is written as a P, okay, over time. Now, this time doesn't have any units, so the time can be 1 second, or it can be 1 minute, or it can be 1 hour. It can be anything you want it to be. And if you make it, just say, well, what's the total interaction time? So if the total interaction takes 5 minutes, we say, two things are going to, it's a huge amount of time. But let's say two things are going to bang into each other, and we've slowed it down so it's 5 minutes. Then I can just make the total time 1 unit of 5 minutes. So I can put a 1 here, 1 unit, 5 minutes long. Now I have F, okay, equals change in momentum, which Newton's clearly saying. He's saying if you want it in units of per second, then you divide it by the time units. But if you want to just say how much total force was there, if I was going to make this into an energy formula and just say how much energy is it, then I don't need this. And then I just have change in momentum is change in force is change in energy. Or I can just say simply momentum. Okay, momentum, which equals mv. Okay, is force. Okay, force applies momentum to you. It gives it to you. You roll across the floor, something across the floor, it gives momentum to atoms in the floor. Momentum is all that's being exchanged. And momentum is energy. Okay, and that's it. This is complete. And Newton was right. And there was no evidence that Newton was wrong. And there's still no evidence that Newton was wrong. There's still no experimental evidence saying MV doesn't give you the right answer. That MV isn't directly related to the force and isn't directly a definition of the energy. How much energy something has, how much energy an asteroid has is completely dependent just on how heavy is it and how fast is it going. There's no fact indicating that the half as light asteroid going twice as fast is going to make more mayhem, is going to move more atoms, is going to... The trick is that it evades friction, though. Fast things evade friction. That's why things go further in clay. So you can evade friction by going faster. You go faster, you don't have to... It's like the lumps in the road. I have a bunch of bumps in the road, and if I go faster, I will fly over the other bumps. I can evade the friction. And so fast things evade friction. The more sensible way to see that as a way of evading is to understand the direction. The faster you're going when you hit something. I'm sorry. Maybe I'll fix that. Yeah. That didn't really help. Anyway, so the faster you're going when you hit something. And so let's say the something could be moving this way or it could be moving this way. It doesn't really matter. It's jiggling. It has its own momentum. And when you hit something fast, then it's more likely that the direction you'll end up with, the final direction when you hit this thing, the faster this is going, all right, so the greater the velocity, the more straight is going to be the byproduct. So if this speed is 100 times this speed, going this way, then this will be 100 times more likely to be in this direction. I mean, it'll be, it'll have a component that's, 100 times more in one direction than the other direction. So the slower something's going compared to the speed of the thing you're hitting, so then the more this motion is in control, and the more likely it is the energy goes this way. Okay, the product goes this way. So you can see simply, I mean, it's just so logical. The faster the object goes, the more likely that you've moved something in the same direction you're going already. So it's like plowing snow, and if you give the snow momentum in front of you, it'll plow the snow in front of it, and it'll plow the snow in front of it, that kind of idea. Or a snow plow actually hitting a snow plow. If I can keep the snow plow moving in the same direction I'm moving, it's still doing work for me. It will hit and exchange and do all of that crap for me in the same direction. So I'm obviously going to get a lot further through something if I keep the motion, if I keep my energy moving in the same direction I'm moving. So if I can push stuff and it stays going in this direction, I have very little friction. If I hit it and it goes off in this direction, it's not going to help me any. I'm going to have to hit the next pin or the next pin. So you could think of it logically as bowling pins. If I can arrange the bowling pins so they're all, in alignment, and I keep the pins going this way. That is, this pin hits this pin, and then this pin hits this pin, and then this pin hits this pin, and this pin hits this pin. If I keep that happening, the ball doesn't have to give up any of its energy to go this entire distance. It gets it all for free. It moves this entire distance for free. But if each one of these pins goes off in a direction that doesn't hit the pin in front of me, I have to hit it with my bowling ball. And then I have to hit this one with my bowling ball. And then I have to hit this one with my ball. And I have to lose my energy, okay, to give them energy. So I don't go very far. That's so obvious and so simple. I mean, I shouldn't have to make the argument that this is logical, this is how the real world works. Okay, if you can keep the energy going in the same direction you're going, you will benefit, okay, in terms of going further, because you don't have to do as much work, because your work is just being recycled. You're giving it to something else that's going to do exactly what you would have done. And it's going to do it for you. It's going to knock all these pins down. So theoretically, I could take any pound bowling ball, and if I can hit the first pin into the second pin without causing any pins to go off in any direction, I could theoretically knock pins down forever. I'll just keep, the pins will just keep transferring the energy and keep getting out of my way, and everything will be fine, and I'll just keep, this ball can go an infinite distance. So it's just about controlling the friction, keeping the friction in the direction you're going, you win. The friction leaves in a direction you're not going, the heat or the transfer in energy, the momentum. If the momentum leaves in some other direction, well, then you're going to be out of luck, because it's not going to help you any. You're not paving the road in the direction you're going. So I mean, this is so mechanically simple. Again, I mean, the fact that I have to argue or defend how mechanically simple that is, how logical it is, how obvious it is that that's how it works. Yeah, it's making me angry just thinking about, there's no way you people are that dumb not to be able to say, yeah, that does make sense. I mean, I can't believe you're that corrupt, vile, petty, disgusting, insipidly stupid, fanatically insane. I mean, what can I call you other than fanatically insane to disagree with this simple principle that if I can keep the pushing force going in exactly the same direction that I'm going, then I'm going to go a lot farther. And if the pushing force ends up going in other directions, I'm not going to go very far at all. Alright, so the formula is not a rational derivative of Newton's mechanics. So how they turn it into Newton's mechanics, okay, like I said, it gets into complexity of derivatives, and it has to do with the fact that they call momentum a vector, and then they call this special kinetic energy a scalar, and they pretend this doesn't have a sign. So because you're squaring something like the number 5, they think you can't have the sign follow the squaring. So if I square a number, -5, I don't know what it is. I don't know whether it's plus or minus. I don't know. Who knows? Or somehow it's automatically all converted to plus. There's no such thing as squaring a number and keeping its sign separate. Which to me makes absolutely no sense as a rule. Or why can't I just keep the sign? 5 is 25 minus 25. What's the big deal? Anyway, so that's how they just create a fake equation where they end up having the notion of velocity, and then they're going to add. They're supposed to be adding acceleration to it. And what they end up doing is having a tracer for the acceleration. Because they don't know which direction it is, they create a dot product that tells them the direction. And the dot product is v again, right? So they end up going v times v. V dot v. And somehow there's an excuse to actually multiply the two v's with each other. When, no, this one was just telling you what direction the energy was. This was for... this was just a tail light blinking. This wasn't supposed to be multiplied times anything. This isn't supposed to be part of the math that you're adding and subtracting and multiplying. This is just to tell you, as I go through the equation, which direction is it moving. Even though you don't need that. But I mean, that's what its purpose was, and they just converted it into an excuse to multiply the velocity times the velocity. When there's no reason to do that. Alright, so the last statement. Friction is not a force, it is merely the transfer of momentum. So friction is just a collision, like any other collision. That's what heat is. Heat is just the fact that you collided with something, you gave it extra momentum. The extra momentum will be, you'll see it as temperature. So temperature, thermometers basically tell you how much energy is in the fact that the atoms themselves, the nucleuses, are moving. And so there's a rate at which they'll bang into each other based on the fact that the atoms themselves, the nucleuses, are moving. Now, the real heat of the universe is in the motion of the electrons. So they're also moving. Okay, and so they contain, but we don't have a thermometer for electron motion. All right, but anyway, that you don't need to know that for this argument. And so all you're doing when you're rolling on a surface is you're transferring your energy. So energy going this way, you're transferring it into energy of pressure because gravity's pushing you down, and you're going to ride over the surface, which means you're going to bang into it, and it's going to be deformed, and in lots of ways you're going to be pushing on it. Okay, and in a direction, and the direction is totally useless to you, and you're just transferring the rotational energy of the wheel, however you want to look at it, and you're just going to have a total connection between how much you started with. You have a certain amount of joules of energy, and you're going to give them to the ground. You're going to give atoms on the ground, you're going to push into them, and they're going to go off in a direction. Okay, and the direction is not going to be the direction you're going, obviously. So you're going to lose that energy, just like you would lose it to an object that went, that you hit, and it went off in the wrong direction. That's the same as friction. I just stick a ball on a string. All right, you bang into the ball, it flies up into the air. You fly right underneath it, so you lost all of that energy because it went up this way. You go right underneath it, and now you've lost all that energy. That's friction. Same thing's happening down here. It's just smaller objects that you're hitting. You're hitting the atoms and vibrating them, moving them in directions. That's all there is. Now with friction you get some of it back because it fights back, so some of it might even push you. A tiny percentage of it will rebound before you've left, and it'll give you a little bit of the energy back. But that's the real universe. It just has to do with direction. If the force leaves, that is the momentum leaves in a direction that isn't the direction you're moving in, you're lost it. Okay, you don't have anybody to do the work for you, to plow the road for you. You're going to have to plow it, and therefore you're not going to go as far. But it's not a counter force. It's just you losing. You giving your momentum to other things. You giving it away. Momentum is something you possess. It's in you. You have it. In the sense of your atoms are moving in that direction, and your atoms can move other atoms in the direction they're moving. They will hit things and they will cause them to move. If they can cause them to move in the same direction they're moving, everything's fine. If they cause them to move in some other direction, then that's energy lost. Lost to the universe, not lost, not destroyed, just lost. Alright, that really should be enough. Hit the key subjects. So if somebody has, can direct me to a single shred of good evidence indicating we've actually measured the extra amount of energy we got out of something, some evidence proving that 10-ton trains going 5 miles an hour have, less energy than 5-ton trains going 10 miles an hour. Except plowing them into clay. Obviously, that's not going to be much of an experiment. Yeah, please. Show me your leader. Show me why I should believe. Show me this great evidence you have. This great physical evidence that any of this crap actually happens in the real world. Ever. That any of this kinetic energy stuff ever really works. Alright, that's probably enough. Yeah. Alright. So, till the next time. Oh yeah, I was going to do comments. Oh yeah, alright, I forgot. Alright, so let me pause for a minute and I'll do a couple of comments in the last video. Yeah, I'm back. Alright, so this was too stupid a comment. I've actually blocked the person. Home Truth, whatever. Farley the troll. But this sounds like a bro comment, actually. So I think Farley now, the cowboy, is now posting comments for Brozo. That's how, subversive these people. They can't play the game in any kind of honest form. Anyway, who else thinks using a person's passing away? I mean, he didn't pass away. I mean, again, so who am I arguing any of this with, right? These are people who really are still stuck in some sort of religious view of the universe or something. Pass away. Oh. No, his brain decided there was no future in it. Okay? He looked at his life and said there's no future in it. There's nothing worth investing in here. That's what he did. He didn't pass away. He killed himself. Alright, so that's the first truth. And the video wasn't about killing yourself. The video was about the fact that this was actually a person who, had capacity or potential, you could argue, far outstripping the common man. Okay, the common Homer Simpson. Yeah, he could do it all better than him. And even in that state, even in a highly efficient form, he still couldn't find good reason to hang around with you retards. He was making a commentary to you, Part of what he was saying was, fuck you, Stephen Bro. Fuck your silly world. Fuck your bullshit. Fuck the chaos. Fuck the nonsense. Fuck you in your defense of the welfare whore. Fuck you in your defense of this slop. This dirty, filthy, stinking planet of creeps that you have defended the creation of. Fuck you. Alright. To smear quantum mechanics. Well, clearly I didn't smear it all that hard. I just made a counter argument. Just like there are people who will argue, just like Leibniz, that, oh, your physics is too sterile. It doesn't have enough God in it. There's not enough, it's showing the world to be too ugly. That's exactly what Leibniz was doing. Okay, and there's people like you out there who are doing all this propagandizing, this lying, about how somehow a pessimistic philosophy means you have to go out and kill yourself. When it's never anything I've advocated. Alright, I defend people having a right to evade suffering. So yeah, if you need to, do it. But I encourage people to stay here and fight. evil. You. Yeah, that's how I encourage them to stay here to just for the fun of pissing on your stupid, stinking grave. But anyway, so I didn't smear quantum mechanics because I clearly stated right in the statement. I said, well, if it wasn't the woo-averse that seduced him, right, into thinking he was going to be eternal anyway, that he can't really die. That's what he believed. He believed he can't really die. All right, so, you know, it's just a fact. It's in his videos, okay? So I clearly didn't smear quantum mechanics. I just pointed out that just like assholes like you, I could sit there and you can sit there and take people who are fundamentally broke and their life has been miserable. No matter what they believe, they're still going to be miserable. Because it's not about having some belief system to fix it. They have real problems, and you're blaming their philosophy and saying, see, with this pessimistic philosophy kills people. Well, no, what kills people is the facts of life. What kills people is the fact that life is difficult. It's unpleasant, a lot of it. It's hard work to survive it, even if you have the tools. And if you're born broken, it's even fucking harder, jackass. But there was no smear of quantum mechanics. There was just an illustration of just how easy it is to blame something. And I stated right in the video that's exactly what I was just doing. And I clearly pointed out it really wouldn't have mattered. Because whatever the underlying problems are, those are what killed him. Okay? He would have used any philosophy as an excuse to create the road out. Alright. Is cheap and disrespectful. So there was nothing cheap or disrespectful in my pointing to the person's life and trying to give it more meaning. That's what I did, and this is just your petty small penis problem showing up again. Okay, that you can't even see that. You're so blinded by your petty little resentment that you can't even see that I did him a tribute, you jackass. Even though I don't agree with a goddamn thing he was thinking, okay? I tributed his life experience and the dedication that created a quite eloquent human being. And it's a tragedy in the sense that we're all less because we don't sit there and do something to create at least the possibility that they can find some reason to hang around and have the conversation and likely call you the fucking butthole you are. He'd likely call you a stinking, lousy piece of shit because he frankly was so much cleaner than you. Anyway. Alright, disrespectful Gary. So that's, bro, I mean, Farley would do that. You might wish everyone would do what you don't have the guts to. So again, what the fuck does that have to do with anything? Again, you're making statements about my courage when you're too much of a coward to make a video explaining what you do believe in. You coward. You despicable, stinking, lousy coward. You won't even answer simple paradox questions. You won't respond to this video and explain how you have all of the evidence and you've done it and you did this and you did that and you proved something. And you certainly won't do it in any kind of honest way because your proof undoes Professor Lewin also. So why don't you tell him he's wrong, you coward. You despicable, slimy piece of shit. You say kinetic energy momentum isn't conserved, and you've proven it? Well, why don't you tell Professor Lewin he's full of shit? You coward. Alright, anyway. But the truth is that most people are not miserable pieces of crap like you. Obviously, most people are stupid, and that's the simple argument. They're too stupid to be miserable. They think it's okay. They don't care. A cat gets run over the street. They just go, dumb animal, who cares? You people don't care about any of the hardship, the pain, the suffering that goes on in this planet because you're retarded. You're little pink balloon chasing retards. You're distracted by absolute nonsense. You're sitting here playing your little tic-tac-toe games in the middle of a slaughterhouse. You're too stupid to be disturbed. Alright. And have lots to live for. Yeah, well, you can say it, and that's just another theory you'll never prove. Yeah, go ahead. What's the big proof? Show me the video. Show me the wonderful tribute to the wonderful things going on, the wonderful lives people are living, the little diaper changing and all the bullshit. Yeah, show me. Show me how great it is, how great they're doing. They're on drugs, okay? They're on medications. They're all way overweight or some other goddamn problem. They're all walking funny, and you're telling me they're all doing just fine. You're pathetic. And it's only after they've been dragged down. So again, he thinks it's the conversation about, you know, the fact that we're living in a bunch of unsustainable, silly notions that people are chasing after, and that's dragging them down, telling them, oh, there's no heaven, you're not going to heaven. There's there's no make it all better. It's like there's no make it all better spray, and it's all going to go away, and it all didn't happen. No, none of that's going to happen. You're not going to some paradise where all this will seem like, oh, this was just such an easy. We did this little bit of work, and we get this huge vacation. Yeah, we get to go on a zillion-year vacation in paradise. La 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 la. Yeah, that ain't gonna. There's no retirement fund, asshole. All right, and kicked again. So how did I kick this asshole? This asshole, okay, is the one who kicked me for no good reason. Who pretended, okay, that we had some kind of common interest when the whole time he was just as aggressively trying to prove his own points. He's the subversive trickster in all of this. By people like you that they start to feel differently. Yeah, well, whatever. I mean, it's just a stupid argument. The fact is they already feel differently, and all they're looking for is good reason, a good explanation. Why? Is the question they're asking, and I happen to be good at answering why questions. So, but fuck you. What a petty turd. Alright, so this other jerk. Anyway, fine, whatever. I mean, you're missing the whole point, The video was about one individual, and you got to bring up some other individual and just distract. See, that's like friction. You're not adding energy in the direction of the video. The energy in the direction of the video this was rather an exceptional human being, and the whole thing, not only did he die pretty much unnoticed by anyone, but he lived that way, and that's the real tragedy. That he has 27 views on some of his videos. That's tragic. So you miss all those points, and you just go in some other direction. Gary, what do you think about the 300 IQ William James Sid's theory, animate and inanimate? Well, it's in my opinion, for a guy in 1920, it's just fine. But it's 1920 physics, so yeah, it's not the right answer. Sorry. And it has to do with a catch on thermal equilibrium, and the fact that you can break a glass and it doesn't appear to be very reversible. That is, you can't rerun the universe backwards and have the glass reform, because you can't put the universe back in the state, okay, that's going to allow all of those vectors to be realigned again, because you have to give them exactly the right momentum. So it is reversible if you can always reverse what every electron is doing. But that's what it requires. You have to reverse it on the scale of electrons. And I don't even know if they could understand something like that back then. But regardless, it's still, he was giving this he was using this as an excuse to, again, anthropomorphize the human being and pretend that animal energy is this special form of extra energy you get by, reversing whatever, the second law of thermodynamics. So what? there's no extra energy. There's no, all that's just horseshit. But anyway, so, I mean, whatever. I argue it's, like I said, some points in it are perfectly valid, but he didn't introduce any new physics, I guess you could argue, so it's not exactly saying anything. And certainly at the end of it, he has a whole bunch of stuff on time travel and stuff, I mean, there's the whole dimensions of time, where, he's smart enough to know that it doesn't really work, so he did call it just speculation. But, no point in trying to create your fourth dimension. There's no place for it. It can't physically happen. No right angles, okay? You can't create a fourth dimension that doesn't fit the same properties as the three dimensions. If it has a different property, it's not a fourth dimension. It's some kind of other thing, but it's not a fourth dimension. So anyway, been there and done that. So I don't know what to say. I mean, it's another tragic story, though. I mean, the guy didn't fare too well in life and dropped dead of a brain aneurysm, which I suppose is sort of ironic. He was sort of just invented. He was like a Tiger Woods, okay? I mean, he was kind of created not so much as a free animal, born free, and he just turned out that way. His parents were a psychologist and a teacher, and they really focused on engineering his intelligence. So, and again, intelligence is just knowledge acquisition. It's just trivia and recording it and maintaining, keeping it, storing it. And so it really, measuring intelligence, you're just measuring how much stuff are you aware of. The processing of the stuff is the more important issue. I mean, intelligence is not falling for things. Like, say, in Star Trek, right? If you were a detective, and you wanted to find out why a planet blew up. Well, if you believe that time travel is possible, well, now there's lots of openings for you to investigate. Lots of places. Oh, well, I have to go to the multiverse, and I have to go here, and I have to think about all these other ways that this could have happened. But if you narrow your universe where time travel isn't possible, then it has to be somebody over there, or somebody over there did it. Okay, it's a lot smaller world you're investigating, and you're less likely to go on dirt roads, and you're less likely to go across lawns, and you're less likely to be, driving through the golf course. I mean, you're less likely to be off the track, and you're more likely to be following something real. And so that's what is more important, I almost argue, than the volume of information you have, is what you do with it, how you process it. And if you fall for stupid things, your intelligence is useless. So I would argue that the intelligence of the other guy, who killed himself, was sort of made moot by the fact that he bought into the whole quantum mechanical, extra-dimensional relativity horseshit, and created a whole fake matrix he was living in. He investigated the problem with life, and he investigated it so poorly because he had these very poor avenues of deduction. And they should have been closed logically, and then he would have stayed in this world and realized we're just bugs, and the only thing that's going to save us from continuing to live a bug's life is we have to fix it. The people here now have to save the future. It can't save itself, and that's the real dilemma. And killing yourself really isn't going to help the future any. But anyway, whatever. Just send a general fuck you to all this bullshit. People are off the subject, and even when you're on the subject, you suck at it. But whatever. This has been a DraftScience video presentation. I'm talking to the wind at the moment, but it's all there is, so it's all I got to work with. And the counter arguments will be nothing relevant, nothing on the subject. So till the next time.